So this is exercise 11.5, and in this exercise we are going to do the questions related with the sum to infinity. Sum to infinity is about the geometric series. Geometric series with some number of terms or the last term. We have we have been dealing in the last exercise or the previous exercise, which was 11.4. Now in 11.5, we will be dealing with the GP or geometric series, which are never ending. So whenever there is no last term, so the series or the geometric series will be called infinite series. So here the task is to find the sum to infinity of the geometric given geometric series. Okay, sum to infinity is symbolized by S and then sign of infinity. And the formula is S infinity is equal to A upon 1 minus R, where A is the first term of the GP and R is the common ratio in the running GP. Okay, so now all these parts are same. So I'm doing part D. So in part D, the given GP is minus 162 plus 108, 108 minus 72 plus 48 and so on. So this is quite simple that the first term is minus 162 and R will be equal to the common ratio 108 upon minus 162, which will be equal to minus 2 upon 3. Now applying the formula sum to infinity, because sum to infinity is equal to S infinity, which is equal to A upon 1 minus R. So this is quite simple to find this. So S infinity is equal to A, which is minus 162 upon 1 minus R. So S infinity is equal to minus 162 upon 1 plus 2 upon 3. So S infinity is equal to minus 162 upon 5 upon 3, which will become equal to 3 upon 5 multiplied by minus 162, and the final answer of sum to infinity of the given GP is coming as minus 97.2. Minus 97.2. So we encircle this in a box. Okay. So this is the answer for question number 1, part D. Question number 2 is the first term of a geometric progression is 10 and the second term is 8. Find the sum to infinity. So in the given GP, the first term is given as A equal to 10 and the second term is given as 8. T2 is given as 8. So we can find the common ratio by dividing the second term by first term. So R will become 4 upon 5. So now sum to infinity using the formula S infinity equal to A upon 1 minus R. So I'm just plugging the values. So A is 10 upon 1 minus R. So this will become equal to 10 upon 1 upon 5. So S infinity is coming out as equal to 50. So this is the answer. Question number 3, the first term of a geometric progression is 300 and the fourth term is minus 2 whole number 2 upon 5. Find the common ratio and the sum to infinity. So in question number 3, this is given that in a GP, A is equal to 300. The first term is equal to 300. And the fourth term is minus 2 whole number 2 upon 5. T4 is equal to minus 2 whole number 2 upon 5. So changing this into improper fraction will become minus 12 upon 5. So now we will use the condition because this is fourth term of a GP. So that is why AR cube will be equal to minus 12 upon 5. So what is the value of A? That is 300. R cube is equal to minus 12 upon 5. So finally, R cube will become equal to minus 1 upon 125. So R is coming out as minus 1 upon 5. So putting the value of R in S infinity formula, sum to infinity, A upon, what is A? A is 300 upon 1 minus R. So S infinity is equal to 300 upon 6 upon 5. 0. Yes. So this will become S infinity is equal to 250. And this is the answer of question number. So in question number 4, this is given that the first four terms of a geometric progression are 1, comma 0.8 square, comma 0.8 power 4, and 0.8 power 6. Find the sum to infinity. So A is 1 and R we can find by 0.8 square upon 1, which will become 0.8 square, and 0.8 square we can write as 0.64. So now finding the sum to infinity using sum to infinity formula, S infinity equal to, because A upon 1 minus R, so A is 1 and 1 minus 0.64. So this will become 1 upon 1 minus 0.64 is equal to 0.36. So this will become equal to finally 25 upon 9 or 2 whole numbers 7 upon 9. And and that's the answer of question number 4. In question number 5, and question number 5 contains two parts, part A and part B. So in part A, we have to write the recurring decibel, which is given as 0.42, and these are dots on it. It means these are recurring decibels as the sum of geometric progression. So first we do part A. So writing the given value, which is 0.42 and two dots on it, it means after every two decimal places, this increases. So this will be equal to 0.42, 0.42 dots on it should be equal to 0.42 plus then 0 point, then two vacancies, and these vacancies will be filled by two zeros, and then 42, and then again 0 point, these two zeros, and then vacancy for the next two, and then 42, and in the same way the series will continue. So this should be the answer. So in part B of question number 5, this is required to use the answer of part A to show that 0.42 dots on it can be written as 14 upon 33. So using the answer of part A, which is this, so what simply we need to do, that is taking 42 common from the series. So the series will become like 0.01 plus 0 point, then three zeros and 1, 1, 2, 3 and 1, then plus 0 0.1, 2, 3, 4, oh, 1, 2, 3, 4, 5, so 5 and then 1 and so on. Right. So now the series which is looking inside the bracket, that is a GP, and then first term of the GP, first term of this GP is A is equal to 0.01, and in the same way R will be equal to, if we do the division of second term by first term, second upon first, so we find R as 0.01. Simply what we need to do, now we have to find the sum to infinity of this series which is inside the bracket. So applying the formula on it, formula on this, so A is 0.01 upon 1 minus R. So this will become equal to 42, 0.01 upon 0.99, which will become after calculation equal to 42 upon 99, 42 upon 99, which is simplifies to 14 upon 33. So this is basically proved. In question number 6, given that the first term of a geometric progression is minus 120 and the sum to infinity is minus 72, find the common ratio and the sum of the first three terms. So in the VP, we are given the first term as minus 120 and the sum to infinity is given as minus 72. We have to find the sum of the first three terms. And we also have to find the common ratio. So this is the requirement. We have to find R and sum of first three terms. So this becomes finite. So S3, S3. Okay, right. So using the sum to infinity formula, which is S infinity is equal to A upon 1 minus R. So if we put the value, sum to infinity is given as minus 72. A is minus 120 and 1 minus R. So 1 minus R will become equal to minus 120 upon minus 72. So this will become 120 upon 72, 5 upon 3. Finally, this will become 5 upon 3. So R will become equal to 1 minus 5 upon 3. So R is coming out as minus 2 upon 3. Now, using R to find the sum of first three terms. So here, because the terms are finite, because these are three terms, we have n. So A will be A, and using the sum to n terms formula, 1 minus R power n whole upon 1 minus R. So this will become equal to minus 120, 1 minus minus 8 upon minus 27. So, sorry, so this will be minus 8 upon 27 upon 1 plus 2 upon 3 means 5 upon 3, which will become equal to 3 upon 5 times minus 120 times 35 upon 27. So making a separator here. So S3 will be equal to 5 and 120 will be cancelled. 5 to the 10 and 5 for the 20. 24. So 24, I think I should show the whole calculation here. So this will become 3 upon 5 times what? Minus 120, then 35 upon 27, 35 upon 27. Okay, so now cancelling these values, we get 5 1s are 5 and 5 2s are 10, 5 4s are 20. Oh, 5 4s are 20. And then this we can cancel this 3 with this 27, and then this 9 and 24 goes with 3, 3 times 8. So finally, S3 is coming out as 8 5s are 40, 28. So 280 upon 3 minus as well, or in decimal, this in mixed fraction, this will become minus 93 whole number, 1 upon 3. And this is the answer. So in question number 7, the second term of a geometric progression is 6.5 and the sum to infinity is 26. Find the common ratio and the first term. So as given in the GP, the second term is 6.5 and the sum to infinity is given as 26. We have to find A and R, right? So using the second term, which will become using the formula of last term, AR is equal to 6.5. So AR is equal to 6.5. So A will become equal to 6.5 upon R. Now making another equation using S infinity equal to 26. So using sum to infinity formula here, S infinity is equal to A upon 1 minus R. Now the value of sum to infinity is given as 26. So using 26 here, A upon 1 minus R. So now using the value of A here from this equation, so 26 will be equal to the value of A from this equation, 6.5 upon R upon 1 minus R. So this will become 26 minus 26 R is equal to 6.5 upon R, multiplying R with all the terms of left hand side. So this will become 26R minus 26R square, and then shifting 6.5 towards left hand side. So this will become 6.5 equal to 0. So now multiplying the whole equation by 10 and rearranging this and taking common as well. So this will become 26 to 60 R square minus 260 R plus 65 equal to 0. Now this can be reduced by dividing the whole equation by 13. So this will become 20r square minus 20r plus 5 equal to 0. This can be reduced further by dividing the whole equation by 5. So 4r square minus 4r plus 1 equal to 0. So now factorizing this equation, we get 4r square minus 2r minus 2r plus 1 equal to 0. So taking 2r as common, so this will become 2r minus 1 and then minus 1 common. So this will be remainder in the bracket as 2r minus 1. So making the separator here, the equation will become 2r minus 1 2r minus 1 equal to 0. So ignoring one of the values because both are same, r will be coming out as r is equal to 1 upon 2. So using this value of r in this equation, we get a is equal to 6.5 upon r, which is 1 upon 2. So a will become equal to 13. So now making it permanent, a r is this and a is this. So this is the answer for r and a. In question number 8, this is given that the second term of a geometric progression is minus 96 and fifth term is 40 whole number 1 upon 2. In part A, we have to find the common ratio and the first term, and in part B, we have to find the sum to infinity. So first, we will do part A. So finding the value of A and R for part A, we will use the given terms as T2 is given as minus 96. So AR is equivalent to T2 and the value of T2 is minus 96. In the same way, T5 is given as 81 upon 2. So T5 using the last term formula for a GP, this will become AR power 4 is equal to 81 upon 2. So now dividing this equation by this equation, we get AR power 4 upon AR, the left hand side divided by left hand side, is equal to 81 upon 2, the right hand side divided by right hand side. So this will become R cube equal to minus 27 upon 64. Minus 27 upon 64. So R will be coming out as minus 3 upon 4. Putting this value of A in this equation, which is AR equal to minus 96. So therefore AR, value of R has come out as minus 3 upon 4 is equal to minus 96. So minus and minus will be cancelled, and 96 can be reduced with 3. So this will become 32, and 32 times 4 is 128. So this is the answer for A and R. So I make it permanent. So this is the answer for part A, for A and R. And part B, we have to find the sum to infinity. So using the sum to infinity formula, S infinity is equal to A upon 1 minus R. So what is the value of A? Value of A is 128 upon 1 minus R. The value of R is minus 3 upon 4. So sum to infinity will be equal to 128 multiplied by this. The denominator will become 4 ones are 4 plus 3, 7 upon 4. So this will be reciprocal and will become 4 upon 7. So sum to infinity is coming out as 73 whole number 1 upon 7. And this is the answer for part B of question number 8. In question number 9, this is given that the first three terms of a geometric progression are 175k, 175 comma k and 63. So these are the first three terms of this GP. Given that all the terms in the progression are positive, so we have to find the value of k in part A and the sum to infinity in part B. So first three terms are 175, k and 63. So first term is 175, the second term is k, and the third term is 63. So because these values or terms are in a GP, so their common difference must be same. So k upon 175, the ratio of second to first must be equal to the ratio of third term to the second term. So this will become equal to k square is equal to 63 multiplied by 175 will become equal to 11025. 11025. So k will become equal to, taking the square root, 105. 105. So this is the answer for part A. Now in part B, we have to find the sum to infinity. So sum to infinity, as we know that sum to infinity is equal to a upon 1 minus r. So a, which is 175 upon 1 minus r. The second term is 105. So 105 upon 75, I'm writing here directly the 105 upon 175. Okay. So which will become equal to s infinity 175 upon 1 minus 3 upon 5. 1 minus 3 upon 5. So s infinity will be equal to 175 multiplied by the answer for the denominator is should be 5 minus 5 minus 3, 2 upon 5. So this will become 5 upon 2. So sum to infinity is coming out as 437.5, which is the answer for part B of question number 9. In question number 10, the second term of a geometric progression is 18 and the fourth term is 1.62. Given that the common ratio is positive, find the common ratio and the first term in part A, and then in part B you have to find the sum to infinity. So in part A we have to find the value of A, means first term, and the common ratio. So using the given information, T2 is 18, so T2 should be equal to AR is equal to 18. So we can call this equation 1. In the same way, uh, T4 can be written as AR cube is equal to 1.62. So dividing this equation by this equation, so this will become AR cube upon AR will be equal to 1.62 upon 18. So this will become equal to R square is equal to 0.09. Therefore, R is coming out as 0.3. So this is the answer for R. Now, putting this value of R in one of the equations, so the easier one is the first one. So therefore, AR is equal to 18. So AR, value of R is 0.3 is equal to 18. So A will be coming out as 60. So this is the answer for A. Now we go towards part B. In part B, we have to find the sum to infinity. So by formula, sum to infinity is equal to A upon 1 minus R. So A is 60 upon 1 minus R. The value of R is 0.3. So S infinity will be equal to 60 upon 0 minus 7, 0.7, sorry, which will become finally equal to 85 whole number 5 upon 7. So this is the answer for part B of question number 10. Question number 11, and given that the first three terms of a geometric progressions are k plus 15, comma, k and k minus 12 respectively, find part A, the value of k, part B, the sum to infinity. As given that the first three terms of a GP are k plus 15, k minus 12, so their common ratio must be same. So what we will do, we'll take the ratio of second to first term, which is k upon k plus 15 equal to, now the ratio of third to second, which is k minus 12 upon k. So this will become k square is equal to k square minus 12k plus 15k. So plus 3k minus 15 multiplied by 12 will become 180. So k square and k square will be cancelled. So 3k will be equal to 180 and k is coming out as 60. So this is the answer for part A of question number 11. Now in part B, we have to find the sum to infinity. So sum to infinity is equal to A upon 1 minus R. So what is A? A is k plus 15. So A is 60. So 60 plus 15 will become 75. And then 1 minus R. 1 minus R. R will be equal to k upon k plus 15. So k is 60 upon the first term has become, after the finding of k, 75. So S infinity is equal to now 75 upon 1 minus 4 upon 5. So this will become equal to 75. 5 on the 5 minus 4, 1 upon 5. So will become 5. So sum to infinity is coming out as 375. Which is the answer of part B of question number 11. In question number 12, The fourth term of a geometric progression is 48, and the sum to infinity is 3 times the first term, means s infinity equal to 3. Find the first term. So we have to find the value of a in question number 12. Now, using the information in question number 12, we take T4 as 48. So this will be AR cube is equal to 48. AR cube is equal to 48. We're using the formula for s to infinity, sum to infinity, which will be equal to sum to infinity, the value of sum to infinity equal to a upon 1 minus r, a upon 1 minus r. So basically this a and this a will be cancelled. So we will have 1 minus r equal to 1 upon 3. So r will be equal to 1 minus 1 upon 3. So r is coming out as 2 upon 3. Using this value of r in this equation, which is AR cube equal to 48. So value of r is 2 upon 3 whole cube equal to 48. So a is equal to 48 times 27 upon 8. So a is coming out as 162. 162. And this is the final answer of question number 12. In question number 13, given that the geometric progression has first term A and the common ratio as R, the sum of the first three terms is 62, means S3 is 62, and the sum to infinity is 62.5. So we have to find the value of A and the value of R in question number 13. So as given, S3 is equal to 62 and S infinity is equal to 62.5. So S3 is equal to 62. So 62. So the formula for sum to n terms will be applied here. So A into 1 minus R power n, which is 3, upon 1 minus R is equal to 62. In the same way, we use the sum to infinity, the value of sum to infinity, which is given in the question as 62.5. So A upon 1 minus R, which is the formula for sum to infinity, A upon 1 minus R is equal to 62.5. So A will become equal to 62.5 times 1 minus R. So we can name this as equation 1. So the same value we should use here in this equation. So the value of A from equation 1 will become 62.5 times 1 minus R cube upon 1 minus r is equal to 62. So here, one thing also, which is not, I did not mention here, 1 minus r as well. So I write 1 minus r here. I should have written here. So anyways, is equal to 62. So this 1 minus r and this 1 minus r will be cancelled. Cancelled. So now we have 1 minus r cube is equal to 62 upon 62.5. 62 upon 62.5. So which will become equal to 124. 1 minus r cube is equal to 620 upon 625. So r cube will be equal to r cube will be equal to 1 minus 1 minus 620 upon 625. So r cube will be equal to 1 minus 124 upon 125. So r cube will be equal to 1 upon 125. So finally r is coming out as 1 upon 5. So this is the answer for r. Now putting this value of r in one of the equations, this is also this is one equation. This is so this one is the easier one. So a upon 1 minus r, the value of r has come out as 1 upon 5 equal to 62.5. So a is equal to 62.5 times 5, 1 is 5 minus 1, 4 upon 5. So this will become 4 upon 5. So a is equal to 62.5 multiplied by 4 upon 5. So the final answer of A is coming out as 50. In question number 14, given that the first term of a geometric progression is 1 and the second term is 2 sin x, where The x is in between minus pi by 2 and plus pi by 2. So x is the angle. Find the set of values of x for which this progression is convergent. So as given, the first term is 1 and the second term, which is T2, is equal to 2 sine x. So at first we should find the common ratio, which can be found by dividing the second term by first term. So this is coming out as 2 sine x. So we have to find the set of values of x for which the GP is convergent. So the series is is convergent when R is in between 1 and minus 1. Okay, so using this condition, we keep R less than 1 and R greater than minus 1. So if we do R, which is 2 sine x greater than minus 1, so x sine x will be greater than minus 1 upon 2 and x will be greater than sine inverse of minus half, which will be coming as minus pi by 6. So the same condition we use for less than 1, we took here for greater than 1. So R is less than 1, so it means 2 sine x is less than 1. So sine x is less than 1 upon 2. So x is less than sine inverse of 1 upon 2. So x is less than pi by 6. So combining these two ranges, the answer of x or the range of x is in between pi by 6 and minus pi by 6, or we can say minus pi by 6 and plus pi by 6. So this one, so x is greater than minus pi by 6. If we read in this way, x is greater than minus pi by 6 and less than pi by 6. So this is the answer. Question number 15. Given that a ball is dropped from a height of 12 meters, after each bounce, it rises to 3/4 of the height of the previous bounce. Find the total vertical distance that the ball travels. So, as given in the question number 15, a ball is dropped from the height of 12 meters. And then after each bound, it rises up to 3/4 of its previous bounce. So we can see that this was 12 meters, this distance, but this distance is reduced by 3/4. So this one, and then this will coming back to the ground and then bounce. When it bounces, then again this will be the 3/4 of the previous. So that is why there is a square in this rise, and then when it is coming to bounce again, that is same as that of its very previous rise. Okay, so if we see that uh, there are two types of series or two types of directions are here. One is down, which is shown by red arrows. This is the down movement or the down traveling of the ball. and the up traveling of the ball is with blue. You can see the blue. So there are basically two series. So I am distributing or dividing or separating these two GPs in up and down. Okay. So basically this is for up. I think I should go with down at first. Okay. So this is for down. So I'm writing here down GP. Okay. So the down GP will be like 12, comma, and then this one 12 into 3 upon 4, and then the third term should be 12 into 3 upon 4 square, and so on. Okay, so first we find the total distance traveled for this GP. So we will apply here the sum to infinity formula. So we apply here sum to infinity, because this is one of the series. So that is why I am giving this name as sum to infinity 1. So A upon 1 minus R is definitely 3 upon 4. So 3 upon 4. So this will become 12 times 4 ones are 4 minus 3, 1 upon 4. So 1 upon 4 will become reciprocal to give 4. So S, or sum to infinity 1, is coming out as 48 meters. Okay. Now we will find the up one, the up, which is shown in the diagram by blue arrow. So this is up here, up GP. So what is up GP if you start from here? So this will be 12 into 3 upon 4. The first term will be this one. Then 12 into 3 upon 4 square. Then 12 into 3 upon 4 cube, and so on. So simplifying this for the first term, we can write this. This will be 9, comma. I'm writing this as it is, or should I write? Okay, I simplify this. This will become 9 upon 16. So 4 threes are 4 fours are. So this will become 27. I write here. I show here. I think 12 into 9 upon 16. And this will be 12 into 27 upon 64, and so on. So this will become 9, and 3s are 4s are. So 27 upon 4, and this will become 4 3s are 4, 16s are. So 3. So this will become 81 upon 16, and so on. Okay. So here you can check the R will remain same, where R is, we can straight away write this 3 upon 4. But how is this 3 upon 4? If you want to check, you can divide 27 upon 4 by 9. So this will become 27 upon 4 into 1 upon 9. So this will become 3 threes are and 3 nines are, then 3 ones are and 3 threes are. So you can check here. So R is coming as 3 upon 4. So now simply after verifying this all, S infinity, we can name this second sum as S infinity 2. So A upon 1 minus R. A is 9 upon 1 minus R. So S infinity 2 is equal to 9 multiplied by 4 on the 4 minus 3. 1 upon 4 means 4. So 36 meters. So the total distance traveled by the ball is the total distance traveled by the ball is equal to ST, which should be equal to the sum of S infinity 1 and S infinity 2, which is 48 plus 36, which is finally equal to 84 meters. And this is the final answer of question number 15.